and talk about margin of error. This is very, very important because with any survey, with any study you do, is the sample going to exactly, perfectly represent the population? And remember, the sample's the little group you're talking to try and understand the whole big thing. Whether it be the million light bulbs you've just made and how long are they going to burn, and you pull out 10 of them, or what's the most popular TV show at 8 p.m. on Thursday night, and you're studying the entire United States. Okay? What winds up happening is these things are never perfect, are they? And the question is, how close are we? And you never know exactly how close you are, but there are some mathematical methods that can be used to give you a border or a boundary of, well, we're somewhere in here. Okay? For example, you might say, hey, would you go find Lauren for me, my daughter? Would you have any idea where to even begin looking? How about I put some boundaries on you, like she's down on main campus in calculus right now? Does that narrow it down some for you? It doesn't tell you the building or the room, but at least you can start going through the schedule and find the calculus classes, and you got a place to start, which is a whole lot better than she's somewhere on planet Earth. Okay? So what this margin of error does is it sets some boundaries. Doesn't tell you exactly where things are, but it tells you within a range, this is about where it's going to be. Okay? When you are given information, for example, 37% prefer fish sticks to corn dogs. Okay? I just made that up. I don't know what the statistics are. That 37% isn't exact because they only talk to a sample, not the entire population. And even the population will change from day to day. Aren't there days you'd rather have a hamburger and other days you'd rather have a corn dog or whatever? Okay? So that'll even fluctuate from day to day. But the question then is, how close are we? Well, there are means of computing the margin of error. How close are we? Margin of error tells us, just as the words tell you or say, it's how big is the margin for the mistake, the misestimate on this particular percentage. Okay? Anytime you are given information, think about this. Anytime you're given information in a survey, for example, on the radio, you're driving in. Okay? Issue number 637 on the ballot is supported by 53% of voters. Now, you got to be careful of a couple of things. First off, does that mean that every single voter who's voting on issue 637 was asked? No. They took a sample, didn't they? And the question is, how close is this to the real deal? Always listen for, after they give you the percentage, with a margin of error of plus or minus, I'm just going to make up some percentage, 6%. That means that the actual percentage could be 6% higher than the 53. It could be 6% lower than the 53. And what this winds up giving you is if you do minus the 6, you're going to get 47%, aren't you? If you do plus the 6, you're going to get 59%. Okay. What that's telling you is somewhere between 47 and 59% of the people are going to vote in favor of this levy or issue, whatever it is. Do you have any idea what's going to happen? You've got no idea, because if 47% support it, is it going to pass? No. If 59% support it, is it going to pass? Yeah, because you just need a simple majority on those things, so over 50% and you got it. Realize that the margin of error is going to let you know if this thing's really going through or not. If they do not give you a margin of error when they also give you the statistic 53%, okay, in Chuck's mind, it's garbage. They haven't told me anything because I don't know how far they are away from the truth, do I? What the margin of error does is it tries to tell you the truth is somewhere in these boundaries. And if they don't set up boundaries, I've got no idea where the truth might really be, and as far as I'm concerned, that was just a waste of radio time. Does it make sense how to get what is called the confidence interval? Okay? Not on the quiz today, but starting next week or the test, it's real fair to ask you to compute the confidence interval given that some percentage are in favor of this with a margin of error of, and they plop out some other number. Are you okay doing that? It's really pretty easy, isn't it? All you got to do is add and subtract. Okay? Man, when was the last time you were in a math class where all it took was adding and subtracting? Yeah. Okay? All right. Now, you can also get into information about the margin of error itself. Remember that we have a sample statistic and a population parameter. Okay, the population is the whole deal, and the sample's trying to give you some statistic that'll fit it. This is really important. We are normally going to assume that there is a 95% confidence that the margin of error really does contain the population's behavior. The margin of error itself can be off. So in that previous one, here, what they were saying here is it's a 4% margin of error. The example I gave, 6% margin of error. That can be wrong. We really don't know what's going on. The whole point of doing the study is, without asking every single person or running every single light bulb till it burns out, short of that, we're just doing a small group, and from that trying to make a forecast for everybody. Okay? For example, okay, we've got planned that tonight we're going to have a cookout by the pond. We're going to have hot dogs and beans and chips and make the little pies in the little pie iron and all that jazz. Okay? If it burns, it burns. If it's raw, it's raw. But we're going to eat it whatever it is because it's a cookout. Okay? We're just going to have fun. Suppose that everybody in here was invited. And I wanted to get some idea of, gosh, how many hot dogs do I need to get? And how much of this, that, and the other thing? And I don't have time to ask everybody. I'm going to ask these three ladies. What do you want for the cookout tonight? Okay, how many hot dogs? And, you know, you want 1 or 2 scoops of baked beans. How much potato chips you going to take? Do you take a chip, you know, a serving like this, or do you take a serving like this? How many pies you going to eat? And from talking to the three of you, I get some idea of how much each person wants. And then from that, I say, well, let's see, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So I'll buy about 6 times as much food as it would take for the three of you. And that should be enough to cover everybody. Now, is that a good sample or not a good sample for projecting? Okay? One of the biggest things that's going to mess it up is all 3 people I surveyed are ladies, but are there men in the room? And everybody knows that men don't eat anywhere near as much as ladies, right? Okay? Yeah, right. Okay? That's going to blow things way off, isn't it? So I could talk to this sample, get an idea, and then say, well, I'll buy a little bit more. That's my margin of error, saying, maybe off a little bit. And then the guys show up and boom, they eat everything, and the ladies are, geez, Chuck, let me call La Rosa's. We'll get some pizza. Right? So what winds up happening here is the margin of error may be accurate, it may not. What we're going to assume, and what in statistics is considered to be the baseline, the minimum standard, is there is a 95% confidence that the margin of error actually represents the population. There is a 95% confidence that the real answer for the population is between these two values. Okay? So you get these two values, and not always, but 95% of the time the real answer is going to be in there, between the low value and the high value. Now there's a catch with the 95%. That means 95 times out of every 100, doesn't it? But that also means that 5 times out of 100, what's going to happen? You're going to either be lower or higher. There are no guarantees, are there? This stuff doesn't guarantee you anything. It just says, well, it's probably going to be in this range, and I'm pretty sure. Pretty sure. How sure is pretty sure? Well, in this case, 95% confident. Whoops, some little birdie just got a headache. Okay. If you look at various studies, you will see the notation a cursive p equals 0.05. That means 95%. P equals 0.01. Any idea what that would mean? 99%. If you get P, and I've seen it in some reports, 0.27. What's that mean? There's only a 73% confidence that the range that we have really has the number in it. They're only 73% confident. That means basically 3 out of 4 times this will be right, and 1 out of 4 times it's wrong. If it's off this far, should you really believe that study very carefully? No. No, no. Okay? If P is bigger than 0.05, if the confidence interval is smaller than 95%, you got to start scratching your head and keeping an eye on it and wondering. Okay? It has to be at least 95% to statistically receive a thumbs up. Now, there are some things where it's very difficult to get a 95% confidence interval. And you just go with what you got and hope for the best. Okay? It depends on the situation in which you're studying. Does that 95% confidence interval make sense? That is really important in statistics. When somebody gives you a margin of error, okay, if you're reading a study and they give the margin of error out to the side, it better, right next to that margin of error, in parentheses, say P equals, and tell you how confident they are that that margin of error is accurate. You can't even get studies report or published if they don't have the little parentheses P equals stuff in it. Because the reviewers are going to say, this is garbage. We don't even know what this means. We don't know if we can trust it or not. Okay? One of the things that was kind of funny, 1948, probably back a year or two before you were born, maybe a few decades before you were born. But anyway, anybody recognize who this is? Truman. There you go. Who's Truman? He was president back in 1948. All of the early said that Dewey was going to win. Right up to the point where the Chicago Tribune, sound like a fairly significant newspaper? It's one of the big ones in Chicago. Okay, the newspapers are always in a hurry. Media, news, regardless what media it's in, is always in a hurry. They want to get the story out before anybody else, right? So the night before, studies suggested that Dewey was going to beat Truman. So the Chicago Tribune printed the newspapers, distributed them so that their kids would be first out in the streets next morning. Paper, paper, get your paper. Dewey beats Truman. But when they woke up the next morning, who was president? Truman. Which makes this kind of a great picture. Ha! Check this one out. They could have one there that says Clinton defeats Trump, couldn't they? Based on what the early reports were. One of the things you also need to keep in mind when you look at this stuff, remember we've talked about biases? Chicago Tribune. Is it lean left or is it lean right? What direction does most of Chicago lean? Left, way left. Which makes it very awkward for the state of Illinois, because most of Illinois is very conservative, except for Chicago. But the catch is, Chicago has so many people in that one little spot that what they vote can override the rest of the state, even though the rest of the state says this is a really bad idea. Okay, that one little section can drive a really bad idea through the whole state. Okay, so that's what this is about, is the Dewey-Truman elections. Okay, so that's got that done. Thought there was another one after that. Does this stuff on margin of error make sense? So when you're given information, you want to, on the radio or wherever it is that you're hearing this, you want to listen for the margin of error. It'll tell you how confident or how big of a range there is on the possible outcome. And on something like the radio, I guess you're just going to have to take their word for it that they're at least 95% confidence interval. But in a printed study, it'll tell you. Okay. Somebody in your family, a friend, somebody you know, I'm trying to remove this further and further from you, comes down with some dreaded disease. Okay? Nobody even heard of it in the family until Uncle Hermie got whatever this is, snuffleumph. Okay? Uncle Hermie has a bad case of snuffleumph. And the doctor says, well, there's this experimental drug that seems to work with snuffleumph, but there is some risk that it could kill Uncle Hermie. But if Uncle Hermie goes untreated, there's an 80% chance he's going to die from snuffleumph untreated. Do you think somebody's in the family is going to get online and start reading up on this drug and on snuffleumph and stuff like that? And there are going to be all kinds of articles out there, aren't there? On the internet, is everything that's out there true? No. And I often make the comment that, I was surfing the web one day and I found a quote from Abraham Lincoln. You know what it said? You can't trust everything that's on the internet. What's wrong with that quote from Abraham Lincoln? He lived back in like the 1860s, 1850s, 1840s. The internet didn't even exist then. So how can he be making a quote about it? Okay? You can find basically anything you want on the internet. Any direction you want on the internet. You have got to be careful if it's something that is relevant to you to research carefully. Okay? One of the things that I make comment of. Anybody ever heard of this? I don't use it. Why not? Because Google tracks you. Which is, for some people they like it because then it fine-tunes to only bring in what they're interested in. Well, very honestly, I'm interested in getting a wide spread. And if I do searches on whatever it might be, global warming, and it figures out, oh man, the 10 articles Chuck opened were all, so we'll start looking for articles that are more like, and ignore the other ones. And the problem is it starts to narrow your view of the world, doesn't it? And whole sections of research just completely drop off from what you can see. Instead, I use something called DuckDuckGo. They do not track you. They do not keep your data. When I do searches on DuckDuckGo, it doesn't know what my preferences were in the last search, and then narrow my next search down to look more like what my preferences are. It gives the whole field. You got to be careful, because when you go out there, you can find all kinds of stuff, or depending on how you do your search, it can narrow you down to tunnel vision very quickly. Did you know that? Whoa, didn't know that one. Maybe you did. Okay, so when you're out there, I use a search engine that doesn't narrow down based on what my preferences were in the previous searches. So I get all kinds of stuff, which is exactly what I want. I've got friends that lean far right, friends that lean far left, friends who are in the middle. I got them all over the place. It's kind of nice. That way I get lots of different ideas and views. Okay? It's fun. Keeps life interesting. How would you like to cook with only salt as your seasoning? Okay? Okay, so you go to some search engine and you pull up this study. Wonder if I should believe this study. Okay, I picked global warming because there's stuff all over the place on global warming. No, Chuck, it's decided. In the politicians' conversations, it's decided. Is there any benefit to politicians for there to be global warming? Ooh, there's an interesting question that you may have never thought about. Are there any political benefits to convince voters that global warming occurs? Or climate change? Let's just leave it as climate change. Are there political benefits? Yes, there are. Did you ever think about that? Wow.
Political benefits to anyone or anything.
That's right. That's exactly right. Okay? So when you hear somebody talking in the political realm, you need to realize, and you're exactly right, there are political benefits to whatever direction they're taking stuff. On an advertisement on TV, a pop-up ad online, they're only going to herald what the benefits are of their product, aren't they? Don't you have to see past that to compare it to the other products? Okay, so you got to be careful. Here's one I'm just throwing out for you. I'll throw out two things. One, has blue ash always looked like this? I mean, trees and mixed mesophilic and temperature range -20 to 105. Has that always been the blue ash area? No. What was here a while ago? Please? Raymond Walters. Think back way past that. Wasn't this a glacier? How thick was that ice? About a mile thick. This was covered with a mile thick layer of ice at one point. What did summer look like then? About like winter. Okay? If you go down to a creek where there are rocks and you pick up one of those big chunks of rock, what do you see all over the place speckled in that rock? Fossils. What kinds of fossils? Trilobites? Yeah, you're doing good if you find trilobites. They're awesome, especially if you find one that's laid out and hasn't been rolled. Most of them are seashells, aren't they? Seashells always occur with glaciers, don't they?
What are you talking about?
That's right. That's insane, Chuck. Seashells aren't around glaciers, are they? No, where do seashells occur? Where do you go if you want to collect seashells? The beach, and the beach is by the ocean. Did you know this used to be a shallow, warm ocean like Hawaii?
Yeah. Big Patrick Owens class.
Okay.
About that.
Please?
Patrick Owens, Cincinnati Biology.
Okay.
The history of like biology around Cincinnati.
Yeah, it's
I'm looking at it
amazing.
right now. It's on the Rush campus.
This area has been all kinds of stuff. Everything from the North Pole to Hawaii has occurred right here in Blue Ash. Okay? One of the catches to the global the climate change thing is there are factors that are difficult to work in. Like, did you know that the sun gets warmer and cooler? The sun goes through cycles. Do you think us driving cars on Earth affects the sun's output? And if you say yes, think about it. It's 93 million miles away, and what from the Earth really gets to the sun? Nothing. The Earth is nothing compared to the sun. The sun affects the Earth doesn't affect the sun. As the sun gets warmer, guess what the Earth's going to do? Get warmer. As the sun goes through a cooler cycle, what's the Earth going to do? Go through a cooler cycle. Okay? There's one thing to think about. Another thing to think about, they're all concerned about CO2, right? What are current levels of CO2? Parts per million. I'm not quite sure, haven't looked at it recently, but it's right around 400 parts per million. See all those green things out there? What do they need in the air to live? Don't they need carbon dioxide? Don't they take in carbon dioxide and turn it into sugar? It's called photosynthesis. Okay? Those plants will die if they don't have enough carbon dioxide. What level of carbon dioxide will start killing them off? About 180 parts per million, all the plants start dying. If the plants die, what happens to us? Dead. Mass extinction, which is what some people are threatening with climate change. Did you know that 400 parts per million historically is very low for the Earth? Well, nobody ever told me that. Everybody's always telling me it's too high. It's actually pretty low. Back when the dinosaurs were here, any idea about what they estimate the CO2 levels were then? About 5,000 parts per million. Earlier times in people history. Okay? After the dinosaurs, not like the Flintstones where they're riding dinosaurs around. Okay? Earlier times where things were going really great, like the Renaissance period, CO2 levels were around 1,000 parts per million. Dude, what are you telling us? All I'm doing is throwing some numbers out there. What I am telling you is people who want to drop the CO2 levels much lower are idiots. That's where the mass extinction comes in, is at 180 parts a million. Yeah, but all the scientists believe in climate change, right? Isn't that true? All PhDs and scientists believe in climate change? There is a petition signed by about 33,000 PhDs and scientists just in the U.S. that say that they do not support, and science does not support, climate change that's man-made. Did you know that? Gosh. Yeah.
So why is the CO2 levels lower than in the past?
There are a variety of things that will cause that. Part of it, I don't know enough to go into. I've read the numbers, okay? I'm not real good on the chemistry. A lot of it has to do with erosion and breakdown of rock, believe it or not. Okay? I've got some articles that in my spare time I'm reading on what fluctuates the CO2 levels, but a lot of it has to do with weathering. Yeah. So, I'm not saying that if you believe one way or the other, you're good or you're bad or whatever. I'm just saying here's some facts. Here's some stuff you may want to go look up. It may be that we're not all going to be dead in 10 years like some politicians are pushing. Okay? They were saying that back in the 70s. In the 70s, they were saying we're all going to freeze to death by 1985. True. It is true. Back in the early 70s, they were saying that by 1985, if things don't change, the Earth's going to freeze over.
So what did they want to change? What did they want to change?
They were after basically the same stuff they are now. Well, I guess it depends on who they is. There were those who wanted to control emissions. I'm all about that. I like being able to go without choking. Okay? That's a real blessing. There are countries where you can't do that. So there's some people who are in it some people want to go after votes. Some people, it's their business to produce this stuff. Here's one. I didn't know this. Did you know that making these windmills, these wind power generators, actually releases more radiation than running a nuclear power plant for a year? Well, Chuck, that's dumb. How can a windmill sitting up there go with the wind release nuclear radiation? Well, those things have magnets inside of them, right? Look where they dig them up. They dig them up in big pits in Russia. In the pits where they dig up the material to make the magnets, has very high concentrations of radioactive material in it. And when they're digging out the magnetic material, they're dumping all the radioactive stuff. They're exposing the radioactive stuff in big piles. In fact, exposing more radioactive material than a nuclear reactor will make in a year. Look it up. Don't believe me. I challenge you to not believe me. I want you to not believe me. Look it up. Okay, so when you get to this stuff, how do you believe it? How do you know if you can even begin to believe it? Because I just threw a bunch of stuff your way that runs contrary to what you're going to hear on the news, doesn't it? Okay? If they can get people worked up and concerned about climate, yes, take all of our money. That's what every politician wants to hear, isn't it? Take our money. It gives them power, it gives them control. Should you believe a study? Most studies are carried out with integrity. Most of the time, they're really trying to find out what is an accurate description of what's going on. Okay, so rule number one, keep in mind, there are a lot of studies out there that they're doing their best to be as accurate as they can. It's not that everybody's out there to get you. Okay? 8 guidelines to keep in mind when you're looking at a study. Okay? Whenever I pick up a study, the first thing I ask myself is, what are they trying to do here? There should be an abstract at the beginning of the study. It's a paragraph, usually in a smaller font, indented, and it's an overview of the study. That should tell you the big idea of what are we trying to do here. When you read that, consider things like, what is the goal of the study? If the goal of the study is to determine how this new medication affects, snuffleups, that's a reasonable goal. They go in not thinking that it works, not thinking it doesn't work. We just want to find out what this stuff does against snuffleups. It's a neutral view of things, which is what you need to have. If in there they start out saying, we just spent $3 billion developing this and we want to prove that it cures snuffleups, that's not a good goal for a study, is it? It's fraught with bias. Okay? Second thing to ask yourself is, what's the population that's being studied? Is it a population that you can clearly define? There are some studies that are difficult to define the population, to define everything that's really going to be involved and studied. There are other populations where it's very specific. Okay? Hey, here's one for you. Women or men more likely to get cancer? Are women or men more likely to get cancer? Women, right? Breast cancer. Right?
It depends on the cancer, really.
Oh, wrongo. One half, you're right, Anthony. 1/2 of all men will experience cancer in their life. 1/3 of all women will experience cancer in their life. That's in the United States. For men, number 1, prostate. For women, I think it's breast, but I'm not sure. So I'm not going to say it is because I haven't seen recent stats on it. Really? Wow. I didn't know that. So ladies, looking good. Okay. Men, better get to the doctor once in a while. That's more than every 80 years or so. Okay, so clearly define what you're studying. Is it clear? Is it something that you can really study? Okay. Here's one for you. Is this an observational or an experimental study? If it's experimental, was it single or double blind? If it's experimental, how were the control and the treatment groups established? Were they properly randomized? You know some of this stuff now, don't you? Are you experts in it? No, but at least you know to look for it. And if you're concerned about it, you can do a little bit more looking around online and find out what defines a good randomization of your groups. Okay? Number 1 is the goal of the study. Number 2 is look at the source. If I'm reading an article that says smoking is healthy for you, here are 3 health benefits. First thing I'm going to do is flip down to the very bottom on the last page and see who funded it. The American Tobacco Association. Is that a good source for studies on the effects of smoking? Do they have a preferred outcome? Yes, they do. Look for biases. Okay? The study should be objective. The people doing the study should be neutral. Neutral meaning they don't care if it turns out that there is a problem with smoking. They don't care if it turns out that there's not a problem with smoking. They don't care which way the study goes. They just want to find out what the numbers say. Yeah?
Did you mean objective, not subjective?
Yes. Okay. Yes, thank you. Oh, a typo. I got to change something else in the slide. Good catch. Way to go. Okay, so after you look at the source, look for biases in the sample. The sample is where the collections were done. If it's people, did they only talk to people in Blue Ash when they're trying to describe how Ohio's going to, whatever it might be? How many corn dogs is Ohio going to eat in the next year? Blue Ash may not be a good indicator for the whole state. Okay? Look for biases. You know what they look like. Now, here's something that gets real uncomfortable. When I'm looking at a study, Chuck has to be careful to put my biases away. Because I really want this study to work, because the outcome really looks good. This is something I'd really like to believe. But when I'm looking at what do I have to do with my own personal preferences? Put them to the side and just say, hey, just the facts. Are there legitimate reasons for concern of bias in the way the sample was taken? And like it or not, I've got to be honest about it. You need to guard against the same yourself. Otherwise, it's easy to be duped. But I really want it to go this way. Yeah, but if that isn't the truth, would you rather have it go with what's comfortable or with what's true? Okay? Here's one that's very easy to overlook. Participation bias. You've all experienced surveys. Ding-a-ling-ling-ling. Hello, this is the Snuffleup Society of America. What do you usually do about that point? Hang it up, right? You have just chosen to not participate. Now, I'm not trying to be mean. I'm being neutral. What kind of a person stays on the line and spends the next 10 minutes poking buttons about the Snuffleup Society? Somebody who's desperate to hear a human voice, right? Okay. It may be somebody who's had 3 family members die of snuffleups. Oh, yeah, I hadn't thought about that. On those surveys that are done, okay, where you have the option of hanging up, it is a very biased sample. The only people who are typically going to stay on are people who have a lot of buy-in and really favor that thing, or they have a lot of buy-in and they really oppose it. You get the 2 extreme views. You don't get the stuff in the middle. If the people are allowed to volunteer and self-select, as in hang up or keep poking buttons, that's a significant problem. Does that make sense? The only people who are going to stick with these kinds of things are people who have a strong feeling one way or another about the issue, and that's not the bulk of the population usually. Okay, 4th thing to look for. Are there problems in defining or measuring the variable of interest? For example, you're doing a study. Married people are happier than single people. That might be something that in psychology they would want to study, or sociology they'd want to study. Actually, most studies do bear out that, believe it or not, it is true. Okay? Now, there are a lot of issues with studying that problem. Can you think of some of them? Yeah. Yeah, how long have they been married? So we're going to have to do a stratified random sample, right? By number of years of marriage or number of years they've been single. Okay. There's an old joke going around. Most married men live longer because they're trying to live long enough to be single again. They live longer because they're being taken better care of. Tough thing to also define happiness. How do you measure happy? How do we measure if Lillian is happier than Katie? How do we measure if Nicole is happier than Sam? How do you measure happiness? Ooh, that's a tough one to measure, isn't it? So when you get into the study, ask yourself, what they are trying to study, is it something that can be really defined, or is this kind of getting out there on the limb? Where it's kind of really tough, and yeah, they're taking a run at it, but let's just see where it goes. Okay. One of the examples that's kind of interesting, illegal drug supplies, stuff coming across the borders. Okay? Typically, if you ask law enforcement, and it's a common, I'm not saying it's right or it's wrong or whatever, I'm just saying it's very common for most in law enforcement to say that only about 10 to 20% of the illegal drugs coming across the border are actually confiscated. My question's always been, well, why are you letting the other 80% in? Because if they know how much else is coming in, you've got to know the total amount coming in, don't you? To compare it to the amount that you've got to get 10 to 20%. Well, to know the total amount coming in, they got to know it's coming, don't they? So why aren't they stopping it? What's this 10 to 20%? Is that an actual statistic? It's a guess. It's a number they're pulling out of the air. Now, am I saying they're bad and they're wrong and they're awful? No, I'm just saying that's not something that's easily studied. It's kind of tough to figure out exactly how much in the way of illegal drugs is crossing the borders. Does that make sense? Okay. Here we go. Police officer in the New York Times. So that's a PFA, pulled from the air. Now, my question is, In that quote, I've got questions too. Is this just a cop that's walking the beat? Or is this somebody who sits in the office all day crunching numbers? Or what's this officer's job? Will they have different views of the world? Yes, they will. Okay? Chuck, you're really crabby about stuff, aren't you? Beware of confounding variables. What's a confounding variable? Well, it's something that creeps into the study that wasn't supposed to be there. Okay? Well, okay, I thought I had an example there. Let's say we're studying the comfort of a particular shoe, a particular ice skate. There we go. Okay? Some ice skates are a lot more comfortable than others. And we give out ice skates to 4 NHL teams and ask them to compare the comfort of this new True skate, True is actually a brand of skate, to Bauer, which is actually a brand of skate. And we want them to compare comfort after having played half a season in a True versus the Bauer. Okay? And the guys all come back and they give their rating of comfort. Now there's a problem with this because some guys, when they play hockey, they wear no socks at all. They want that skate so tight that there's not room for a sock. And they just strap it on, and away they go. Please? Yeah, well, I don't know if you've ever been around hockey equipment. It's far worse than football equipment. Okay? So athlete's foot's the least of their concerns. Or is but one of many concerns. Put it like that. Some guys wear a real thin wicking sock. Some guys wear a real thick sock. Do you think the type of sock or no sock that they wear is also going to affect the fit? Yeah. And if all they're talking about is the fit, the boot, the shape of the boot, and the liner in the boot, and they ignore the fact that the guys are wearing different types of socks, is that going to be a good study? Well, there's going to be an issue with it because you got something coming in there that you really didn't exactly depend or contend on having in there, and that's, geez, some of the guys wear socks, some of them don't, and they wear different kinds of socks, and it messed up the whole study. Okay? So that's guideline number 5. There are 8 of them total. We'll get to some more of them Monday, but guess what it's time for?